Today we're going to be looking at characteristics of linear functions. If you look on the top left-hand corner, it asks me for the linear parent function equation. You should know that it's y equals x. And then it asks me for my domain and range. And what do we know about domain and range? Every time I have a continuous graph, that's right, I'm going to have all real numbers. So what I would like for you to do is fill out the domain and range, sketch the graph of y equals x, and fill out this table. Now you could choose other points. You don't have to use decimals, but what I want you to notice is that there are decimals, we could have fractions, and we could have whole numbers. So what do you notice on a pattern for the x and y when we look at the table? You should notice that each x and y value, they're the same. So what happens as my x values increase or they get larger? So do my y values. So here under the next question, I want you to write the answer for the bullet point. Okay, it says what patterns do you observe in the table and the graph of the linear parent function? Okay, now once you copy this down, let's look at the characteristics. We're going to review some of the formulas. Okay, we have characteristics of linear functions such as slopes, intercepts, and equations. They've been addressed in previous math courses, but I just want to make sure that you understand what equation goes with what. So here let's look at the forms of linear equations. My first form is standard form. I have ax plus by equals c. Make sure you put a note somewhere on your paper that I cannot have fractions in standard form and that a always has to be positive. Okay, let's look at the next one. The next one is going to be your point slope formula. This is y minus y1 equals m times x minus x1. And then the last one, which most of you are familiar with, is your slope-intercept form. That's y equals mx plus b, where m is the slope and b is the y-intercept. So let's write down some characteristics. Look for slope-intercept form. It says in the slope-intercept form, we're going to explain how changes in m, the slope, and b, the y-intercept, affect the graph of the parent function. Now, you're going to see a lot of information under here. I want you to copy every piece of it down. That way you understand the definitions of my slope and b for my y-intercept. Now, you might need to pause the video right now so you could copy it down because I'm going to move on. Turn to the next page. We're talking about finding slope. So how would you define slope? I'm sure most of you would tell me rise over run. And that's correct, but I also want you to write down a few other words. I want you to write down rate of change and the change of x divided by the change in y. Now let's explain how we can find slope based on what information that we're given. So the first one we're talking about is a graph. If I look at my graph and I'm given 2 points on the graph, I'm going to use rise over run. So here, if I count up 4 units and I count to the right 2 units, so both of those would be positive, my slope is 4 over 2. Well, 4 divided by 2 is 2. So my slope for the graph is going to be a positive 2. The next example is a table. Here is where we'd use the change in y over the change in x. So here, if I do the difference from 2 to 4, I know that that is 2. And I know from 5 to 19, my difference is 14. So since it's y over x, I would have 14 divided by 2. And that's where I get that the slope is equal to 7. Let's look if I give you 2 points. Now you should understand how to do this because I went over this in your low grade makeup video. Here I'm going to use the formula for slope. It's y2 minus y1 divided by x2 minus x1. So here after I do my subtraction, I should get a slope of negative 8 over 5. And then the last one is going to be an equation. Now most of you probably looked at a and b and could easily give me what the slope was. But what about problem C? C, in order for me to be able to find the slope, I would have to solve the equation for y, and then I would be able to locate the slope. So here, your slope for A was negative 2. The slope for B was 2/3. And once I solved C, I should get that a slope is negative 3. Now that we've talked about slope, let's talk a little bit about what an intercept is. So, an intercept is going to be a point where a line intersects or crosses the x or the y axis. the point where a line intersects or crosses the x or the y axis. So here we're going to explain how to find the y-intercept from each representation. So if I look at a graph, I'm going to determine where the line would cross the y-axis. That's how I would know where my y-intercept is. If I had a table, I would look for the point 0, y. Now y is going to be the number where it crosses the y-axis. If I'm given the information for y equals mx plus b, here I'm just going to identify what the b value is. And then the last one from any equation, here I'm going to plug in x equals 0 and then solve for y. Now for the equations, I will give y'all some examples in a little bit. So what if we're trying to find an x-intercept? Here, if I have a graph, I'm going to determine where the line crosses the x-axis. From a table, I'm going to look at the point x comma 0, again, x being the number where it crosses the x-axis. And for an equation, I'm going to plug in y equals 0, and then I'm going to solve for x. Now, we're going to use this information in a little bit to work some of the examples. So I want you to flip the page, and let's go over a few more definitions before we work the sample problems. Now, the next two sections in the notes are going to be very important. This is going to help you determine what equation you should use when you have a specific type of problem. So here for finding equations, there's several ways to determine the equation of a line depending on the information that you are given. So let's look at the first one. If I am given the slope and the y-intercept, here I'll use the slope-intercept form, which most of you are familiar with, y equals mx plus b, and I can just write an equation from that. But what if I'm given the slope and a coordinate for a point? This is where I would use point slope formula. My y minus y1 equals m times x minus x1. Now what if I'm given just two coordinates? Here I'm actually going to have to use two specific formulas. So it is a two-step problem. Not only do I have to use the slope formula to find slope, once I find the slope, I can choose any point and plug in the slope and the point into my point slope formula. So again, if I give you 2 points, it is a two-part problem. And then the last one is going to be a table of data. Here, I'm going to actually show y'all how to do it in the calculator. Again, most of you are familiar with STAT on the calculator, but I will go over this. So for right now, just write a calculator's list. Now the last thing I want to go over is special lines and slopes. So here's where I need you to understand the difference between horizontal lines, vertical lines, parallel lines, and perpendicular lines. So let's first look at horizontal lines. If I have a horizontal line, my slope is going to be 0. So my slope is equal to 0. And here's my sample equation. It says y equals the number sign. So for instance, I could write y equals 3. Okay, anything that has y equals and it's just a number, that's a horizontal line. If I look at my vertical line, remember a vertical line goes up and down. This has an undefined slope. And here I have x equals a number. So here I could have x equals 2. Anything that's x equals will give you a vertical line. Now for parallel lines, here I want you to understand that my slope is the same. If I tell you that the slope is parallel to a certain equation, that means my slopes are the same. So for instance, y equals 2x plus 3 and y equals 2x minus 7. My 2 is the slope. That means those lines are parallel. And then the last one is going to be a perpendicular line. Here, the slopes of perpendicular lines are opposite reciprocals. You guys have heard me use that terminology before. So an example would be if I had y equals 2x plus 3, my 2 is positive. It's just like saying 2 over 1. Here, I would change the sign, so I have a negative. And I'm going to flip my fraction. That's what a reciprocal is. That's why I have 1 over 2. So y equals negative 1/2 x minus 7 is a perpendicular line to y equals 2x plus 3. So once you get all this copied down, I'm going to work a few sample problems for you, and then you guys are going to finish the rest in class. So let's look at a few sample problems. Okay, looking at problem number 1 under my sample problems. Here, I came up with a table based on the graph. So if you fill out this table, my coordinate points are 1, -3, 3, 1, 4, 3, 5, 5, and I added another one, 0, 5. Now on the right-hand side, for A, it tells me that I need to fill in the table of values, which I just did. Then it tells me I need to find the slope. So in order to find the slope, we're going to use the equation y minus y divided by x minus x. So I want you to determine the slope, and let's see if we get the same answer. So once I solve for that, I should have had 3 minus 1 divided by 4 minus 3, or you could have chosen 2 other points, but I still should have ended up with 2 over 1, and so my slope should have been 2. So m in my equation is 2. Part C says I'm going to find the equation for a line. Now let's think about what we've been given. We found the slope. Now we've been given some points, but there's one particular point that will make this equation a whole lot easier than having to solve anything. What did I give you in that table? That's right, I gave you the y-intercept. So here I could just use my intercept form. Y equals mx plus b, where m was the 2 that we just found in slope, and my 5 is where my graph crosses the y-axis. So here I have y equals 2x minus 5. Now part D tells me I'm going to find the intercepts. Well, we just found your y-intercept, which was 0, -5. And now we're going to determine the x-intercept. That should be a -5. And also on your table, make sure it says -5. I forgot the negative. So for my x-intercept, I can't determine exactly where it crosses the x-intercept. Now I can estimate, but I want an exact answer. So go back to my notes. What did it tell me to do if I couldn't find the x-intercept based on the graph? I'm going to plug in a 0 for y, and we're going to solve. So here, I plugged in a 0. So I have 0 equals 2x plus 5, and I need to get x by itself. So I could subtract the 2x to the left-hand side, and what's always my last step in solving an equation? Division. So I divide both sides by -2, so I end up with x equals -5/2. So if I take that and I rewrite it as a coordinate point, my x-intercept should be -5/2, 0. Okay, so let's turn the page and let's look at the next sample. All right, let's look at example number 4. Here it tells me for the given information, we're going to find the equation of the line. Please underline where it says both slope-intercept and standard form. That means I will have 2 answers. If you only do one, I'm not even going to grade it. I better have both. So on question number 4, it says I have a slope of -1/2, and it contains the point -2, 5. So if I go back to my notes, it tells me what formula I need to use if I'm given a slope and a point. You're right, it's called point slope. So here, if I use y minus y1 equals m times x minus x1, my equation should look as such. Y minus 5 equals -1/2 parenthesis x minus a -2. Please don't forget to make sure that you have the minus and the negative. So once I have 2 negatives, what does it become? That's right, it's going to become a positive. So once I distribute the -1/2, I should have y minus 5 equals -1/2 x minus 1. Now from here, I'm going to add 5 to both sides, and that will give me the new equation of y equals -1/2 x plus 4. Now that is my answer for point slope formula. But what it also asked me to do is to find this information in standard form. So if you go back to your notes in standard form, there was 2 things I had you write down. Number 1, I had to not have fractions, and number 2, I couldn't have a negative for A. So let's work this one out. Okay, starting from the answer from the previous example. Here, in order to get my answer into standard form, I have to move the -1/2 to the other side of the equation, which gives me 1/2 x plus y equals 4. Now, how do I get rid of a fraction? That's right, I multiply by its reciprocal. So once I do that on both sides of the equation, I should get that y equals or excuse me, x plus 2y equals 8.